Assalamu alaikum. Ji, I'm Dr. Akash Jamil, serving as lecturer in the Department of Rangeland Forestry and Wildlife. Today we are discussing about traditional ecological knowledge for monitoring rangeland conditions, a case study we conducted in Thal, Pakistan. So first of all, we will describe what is rangeland. Rangeland is a large amount of area, vast area that is covered with grasses that are not managed by any kind of human interference, but they grow naturally. So rangelands, as we know, in Pakistan it covers about 60% of its land area. It is the most land area occupied by any land use. It is very critical for national economy and livestock sector, as it supports about 30 to 40% of the livestock and contributes about 11 to 12% of Pakistan's GDP. So, having regard all of this, there are about 40 to 50% of Pakistan rangeland is degrading rapidly, and it is mainly because of over exploitation of the resource, unmanaged exploitation of the resource, and unsustainable utilization of the resources, which lacks planning as well as management. So, as we know that rangelands are very famous for having discoveries like minerals and very valuable resources such as coal, gold, and chromium and chromite as well. In Pakistan, recently gold mines have been discovered, and that is from Dracotic, and it is a rangeland in Balochistan. Gold deposits were recently discovered as well, and that was also from a rangeland that is present in Thar. And salt, as you know, Pakistan is about one of the most largest producing countries of salt in the world, and it is also from a rangeland, which is Potwar rangeland. So, first of all, we would like to know that what is traditional ecological knowledge? It is a knowledge that is held by indigenous communities about their surrounding environment, surrounding resources. It is normally passed from generation to generation and is known as very ancient knowledge that has very potency among mm, among the people that are using it, and it has very important for the conservation of the resources and utilization of these resources. These knowledge systems actually guide those human beings and those communities to graze, that how should they graze, uh, which pattern should they graze, and when they have to shift from that area to another area. So these indigenous rangeland indigenous knowledge usually help them assess techniques like forage indicators, livestock condition, their soil color, and having information about these components then let them decide grazing intensity and movement. So, as we know about tech now, tech is a global phenomena, global, and many people have studied this tech in different parts of the countries, in different parts of the world. Specifically in Kenya, there is a study in which scientists found that past observations often matched or exceeded scientific range assessments in accuracy. For example, Turkana herders in Kenya accurately classified plant platability, range degradation, and drought onset only using these indicators, like grass seeds presence or roof resistance, which let them know that either the soil is hard or soft. One of the key insights is that tech allows adaptive decision making. Communities shift herds based on ecological feedback like reduced vegetation or water long before satellite data detects. Even satellite data cannot detect what on ground situation is detected by these traditional knowledge. So landscape level wisdom embedded in tech, what is now called as landscape ethnoecological knowledge, in which herders understand ecological boundaries, seasonal cycles, and even interspecific species interactions across vast terrains. So, what is the problem statement? Why do we need tech? We need tech because Pakistan rangelands are degrading rapidly, and one of the most common factor in this degradation is the lack of mm, integration between the conventional knowledge and the scientific knowledge. In Pakistan, there has been history that we ignore local stakeholders. We ignore people that are directly benefiting from them. We ignore people who are actually caring for them. But we impose top to bottom approach that usually disrupts all the ecosystem systems as well, and the people there as well. Their livelihood is also destroyed. So local herders' knowledge is should not be overlooked. It is overlooked. So that's why there is need for integrating traditional ecological knowledge that is possessed by the local people. And another problem is that there is no study, very few studies regarding traditional ecological knowledge in Pakistan. So what we are trying to do, what is the significance of the study? The significance of the study is to bridge a gap between the science and traditional knowledge. So we want to integrate tech into rangeland management frameworks, promoting cultural relevance, community participation, and ecological resilience. So by doing this, we can actually integrate both the scientific stuff as well as traditional stuff, and try to make a conventional framework in which can be distributed to the rangeland department, and then it would devise a policy and a formulation work so that, yeah, the people there are also looked after, and when they would be looked after, the resources would also be looked after. So need for integrated monitoring. So not only scientific techniques are should to be involved in these monitoring, but the conventional people knowledge should also be involved in monitoring these resources, which can uh, enhance accuracy and real-time decision making. So undocumented local indicators, that is was a big problem, is also identified by the studies. We would be documenting the traditional ecological knowledge that the people possesses, and that is being transferred from generation to generation, and still it is not identified or documented in scientific literature. So this study would also help it document this traditional knowledge into scientific literature. So there are four objectives of the study. The first objective is that we want to document tech herders in Thal rangelands, identify the key ethno-ecological indicators for assessing rangeland conditions, and exploring potential for incorporating tech into formal monitoring, thus providing recommendations for integrated rangelands and management. So the study site that we selected was Thal rangeland. Thal rangeland is the third most largest rangeland in the Pakistan and second most largest rangeland in the Punjab. And so it is a subtropical sandy area that covers about 2.5 million hectares. It is bounded by Indus River, Jhelum River, and Chenab River floodplains. It is characterized by scanty trees, sparse grasses, herbs, and shrubs. Extreme temperatures in which 50 degrees centigrade is experienced in the summer, and it can fall up to 0 degrees C in the winters. So the study design that we employed was ethno-ecological interview-based survey. We conducted it in August to September 2022 in the post-monsoon season. Two-stage approach was used: focus group discussion, semi-structured questionnaires, and the sampling we conducted was about 60 respondents from 6 villages in 2 districts. So this time was so why was this time of the year chosen? We chose this time specifically as after monsoon the climate is more suitable for more growing of the forages as the density and diversity of forages increases, and the people there gets on in the field with their livestock and get ready for grazing their animals. So they are abundant in that period. So that's why we selected this period so that we could obtain maximum respondents from for the survey. So we liaised with the Forester and Range Management Department that helped us in selecting the villages and helped us in locating the herders and contacting us with the elderly people. So we selected knowledgeable elders and landless herders. So we included both the people having lands and having animals, and the people that having do not had lands but had herds of livestock for grazing. So we conducted focus group discussion in villages, administered semi-structured questionnaires, recorded demographic, socioeconomic, and tech indicator data. So our study limitation included small sample size. It was small sample size was because of the people, specifically local. herders that were landless and usually roam about in the rangeland. And the rangeland we know is very big, it's very vast, and the people used to cover long distances. So identifying and tracking them at once was very difficult. So we found a bit less amount of people to get interview with, because they were nomadic herders, and also they were very quite hesitant for doing an interview, as they were feared that their data would be used for some NGO stuff. And time constraint was another factor that had our sampling size a bit lowered. So the first of all, socioeconomic determinants we gathered were that about 43% middle-aged people were mostly present in that area, and there were mostly settlers, permanent settled, the people who were settled there, and even they do not had land there, but they were settled here there and were grazing their livestock there. About 63% had their own land holdings, but they were mostly relied on the livestock for grazing. So, while most of the people were illiterate, but 65% of them were educating their children. And according to the pictures as well, you can see that it was very infrastructure was about, um, it was very low infrastructure was there. Not much advancement was there. So about 43.3% people lived in mud houses. So livestock holdings of that people were also mostly were constituted of small ruminants and having small herd size, about 20 to 40 animals. They were not having much bigger sizes. Even cattle, they had small herds, about 5 to 10 animals, and camels were even smaller, about only 1 to 2 animals. And most of the people had their own herds, and most of the people had quite their share of livestock management experience. So the traditional ecological knowledge, the first we had found was vegetation indicators. What were the vegetation related indicators that the herders were using for deciding their grazing practices? First of all, it was the biodiversity of palatable species was an extremely important factor that governed their grazing intensity as well as their grazing patterns as well. Again, the palatability, the density of the palatable species was another factor in which, when they seem that there are more palatable species to eat for the livestock, this means that the rangeland condition is good and they have to stay there for longer period. While if their forage availability is increasing day by day, and the forage availability is easy to find for the animals, then they used to stick there in that area and do not shift that area for in order to get more in order to get more forages for their animals. Ephemeral plants was another indicator that showed that the soil is moist, and it will stay more conducive for the forages to grow in the coming months. So that's why they would stay there as well. Landscape indicator was another indicator in which they use the landscape to indicate whether they should stay in that area or could move from that area. So if the leaf litter was present more in the soil, the people tend to remain there, and it used to mean that there is more conduciveness for the plants to grow, for forages to grow. If soil dispersion was getting more, this showed that again the soil care could be led to the quite amount of degradation. So 48.3% observed increase in bare soil, which discussed and which showed that if the bare soil is increasing, the people will leave the soil, leave the area for better forage production. And a sand dune shifting was another phenomena which showed that the land is going towards degradation. So the animal based indicators were that if the people could observe that suddenly their animals and are getting sick, or they are suddenly dying. So this showed that the amount of unpalatable species are increasing. If the animals are getting abortion much frequently, this also showed that the toxic plants are getting increasing. and this is not suitable for this for the animals to graze in that place, and they would change their grazing pattern and change their grazing scheme. If the dung shape was another factor, if the dung was runny and off shape, they know better which kind of dung is healthy for their animals. So if the dung shape was getting a bit off, this also showed that the range area is not suitable for them to graze, and then they would also change it. So environmental indicators were mostly associated with extreme temperatures. Extreme temperatures depicted that people were leaving that area because of high temperature, and 65% had no opinion on using rainfall as an indicator. Water availability and quality considered were also important. Key findings. The key findings were the herders used a diverse set of tech indicators. Indicators aligned with scientific ecological principles. Animal-based indicators are highly valued by herders. Vegetation and landscape indicators provide long-term insights, and environmental indicators reflect climate change impact. So what were the implications? The implications were that the tech can complement scientific monitoring methods potential for developing integrated indicators. Opportunity for participatory rangeland management, need for a common language between herders and scientists, and tech can inform climate change adaptation strategies. Future recommendations, what we recommend is to conduct larger scale studies across diverse Pakistani rangelands, develop standardized protocols for documenting tech, create platforms for knowledge exchange between herders and scientists, integrate tech into formal rangeland monitoring, and explore use of technology to record and analyze tech. So this was our study, and this presentation is based upon a study that we conducted in 2022, 2021 to 22, and this was also published in a very reputable journal that you can see. So this was all from this topic. Hope you would have gained a better insight on traditional ecological knowledge, and I hope that you would search this topic more. Thank you.